This video is on direct and inverse variation. We've done a foldable already on the direct variation, so this is going to be a refresher. You can find more of this on your interactive notebook page 66, I think, or 67. 66 and 67, I believe. All right, let's get started. For direct variation, it is the same as a proportional relationship. The equation looks like y equals k times x, or k equals y divided by x. Okay? That's a direct variation where k is the constant of variation. Okay? So from a table, we need something that is going to be consistent, okay? So essentially that change in y over the change in x, a constant rate of change or a constant slope. So if x is going up by 1 each time, let's say that y goes up by 3 each time. Okay? If you'll recall from direct variation previously, the graph has to go straight through the origin. Mine does not look like it does, but it's supposed to. Okay? All right, now let's look. Tell whether the equation, table, or graph represents a direct variation. Okay? If you'll recall, there is not allowed to be a constant, so this is no. That is not a direct variation because this means it starts at 1 on the y-axis, and our direct variation cannot. It has to go through the origin. But number 2, 6x is. X changes. It's being multiplied by 6 each time. That's a yes. That does look like my equation. It's good. All right, bottles of soda and people. We're going up by 2, and then here we're going up by 8. And then, but 16 to 24 is not 8. Yes, it is. Yes, it is. Of course it is. Okay, so our change in y, 8 over 2, change in y, 8 divided by the change in x over 2, of course. So this is a yes. Sorry about that. All right, number 4, I'm going up by 1, and then up by 2, and then up by 4. But let's see if this is consistent. 5 to 10, up by 5. So this is a change in 5 over 1. 10 to 15 is also just a change in 5. So 5 over 2 is not the same as 5 over 1, and then this is also 5 over 4. This is a no. This is not a direct variation. And then let's look at the graphs. We said it had to go through the origin, so this is a yes, and this graph does not go through the origin, and it is straight, so this is a no. Okay? That's direct variation, a little bit of a refresher. For inverse variation, our equation is different. It's when y is the constant of variation divided by x, or x times y is a constant. Don't forget that k is the constant. Okay? Now, if, say, my x is 1 and my y is 24, the constant is y times x. So this constant is 24. Well, I need this constant to also be 24. What else can I have multiply? I could do 2 by 12, that constant is still 24. Or 3 by 8. Or 4 by 6. All have that constant of 24. Okay, so that's, I'm multiplying here instead of dividing like I did with the direct variation. Okay, now we're going to look at a graph. The graph of an inverse variation or like a rational function. It's going to look something like this. Okay, so they get close to the y and x-axis, but they don't touch. And that's one function or one inverse variation. Okay? You'll learn more about that when we learn about rational functions. Okay? So, 7. Tell whether each relationship is an inverse variation, a direct variation, or neither. Okay? So, let's see if it's direct. 10, from 10 to 5 is down 5, then down 1, and then down 2. And this is by 10, by 5, and by 25. So that's not direct variation. The change in y and change in x are not consistent. They're not constant. But let's multiply. 10 times 10 is 100. 20 times 5 is 100. 25 is 100. Okay, so very good. It is an inverse variation. All right, number 8, we have from 16 to 12, I'm going down 4 and down 4. Okay, so from 32 to 24, I'm going down 8 and then down 12. So that's not direct variation. Well, 32 times 16 is 512. 24 times 12 is 288. So all of a sudden, I know that these multiply to something completely different than what these multiply to. So this is neither direct or inverse variation. 9. Again, so let's see. Change in x, I'm going up 4. I'm going up 2, and then I'm going up 10. All right, but this is going up 20, up 10, and up 50. So let's see, 20 over 4 is 5, 10 over 2 is 5, and 50 over 10 is 5. So this is a direct variation. Okay. The last table, I'm going down 1 each time, and then I'm going up 1 and then up 3, so it's not direct in variation. 1 times 2 is 2, 3 times 2 is 6, so this is neither. The variations are not direct nor indirect. Okay? 11, it is a straight line and it's going through that origin, so this is direct variation. And this rational function is getting close to the x and y axis, but not touching it. This is inverse variation. Okay? Now, what I want you to do on your left-hand page is I want you to create your own examples of inverse variation. I want you to create your own equation, putting in numbers, okay? I want you to sketch a graph, and I want you to give me two different tables that have an inverse variation. The code word for this lesson is apple.